Uh, okay. Hello, Mr. Huang. Uh, yeah, this is group 4 Maths Amoa presentation. Unfortunately, Isaac here. I'm going to be doing it myself because we split up the work. So, yeah, let's go. So this is scope. We're going to show you task 1, task 2, and task 3. And this is task 4. Yeah. So that's one. Task 1, what's trigonometry? What's Pythagoras theorem? What are trig ratios? So basically trigonometry, in Greek, the word trigonometry comes from the Greek trigon, which means triangle, and metron, which means measure. It's a branch of mathematics that studies triangles and the relationship between their sides. So basically you can use the trigonometric functions and try to find the sides and angles in the right angle triangle or any triangle, I think. Yeah, any triangle. Yeah. So basic trigonometry are often taught in school, which you are teaching me now, and it's fundamental in astronomy and navigation. Okay. So, okay, so you can't really see the what is Pythagoras theorem, but yeah, this is a slide. What is Pythagoras theorem? Okay, in mathematics, the Pythagoras theorem, in the Pythagoras theorem, it's the relationship between the three sides of a right angle triangle. So in any right angle triangle, the area of the square whose side is the hypotenuse is equal to the sum of the areas of the other two sides. So the wait the formula for it is a square plus b square equals to c square. So c represents the length of the hypotenuse, a and b represent the lengths of the other two sides. What are trig ratios? Trig ratios are used to find the sides of a right angle triangle besides using Pythagoras theorem with the given dimensions such as reference angle, a side, and the formula for it is tuakaso. So basically tuakaso is the easier way to memorize the formulas. So tua is tangent equals to hypotenuse over adjacent, ka is cosine equals to adjacent over hypotenuse, and so is sine equals to opposite over hypotenuse. I know you know that, but yeah, you may be asking what is opposite, adjacent, and hypotenuse. Okay, sorry, the adjacent is supposed to be the other side, which is not there because I forgot to. The picture didn't have it. Yeah, so you just have to use the reference angle. So using the reference angle, you can identify the adjacent, opposite, and hypotenuse. Task 2. How to use trigonometry in real life? What is the line of work? Which theorem or ratio did they use? And we have to provide a sketch of how the answer was found. Okay. Sorry, on top is also cut off a bit. So how is trigonometry used in real life? The following slides will show you how to use trigonometry in real life. It will also show what theorem was used and the line of work. I found out 3 examples, and yeah, I'm going to show you 3 examples. The first example is finding the distance between celestial bodies. Basically, you just have to you're finding the distance between the stuff in space, I think. Yeah, so for this example, the triangle formed between Saturn, Earth, and the Sun is not a right angle triangle, so we either have to use sine rule or cosine rule. So we have to find angle C using the sine rule. But first we have to find angle C, and then we have to apply the sine rule to find side C, which later can be used to find the other sides. And finally, the distance of the celestial bodies. Yeah. Okay, the example 2 is cut off also, so you can't really see it. So example 2 is finding the height of buildings and other stuff. So first, people have to find a point which is parallel from the building. Next, we need to find an angle of elevation, and we have to make it and we have to find the side AC, which is depicted in the picture. Yeah, so using the trig ratios, the height can be found. So we have to use tangent angle of elevation equals to from the point of the building over side AC. So yeah, we can find side AC using that. Third example is finding the distance from the sea to an island, or vice versa. First, we have to find the point where the unknown distance meets the beach shore and name it AX. And we can use that distance and using the trig ratio to our TOA, which is tangent 40 equals to unknown distance AX. Yeah, and by the way, I got the 40 from the picture. Yeah. So task 3, we have for task 3 is the question and the job prospects. So my group has chosen the landscape helper job. Yeah, and the following slide will show you how we carried out our questions. Okay, so the job prospect 1, the question is asking which plot of land would you rather mow, the A or B combined or C, and I don't think it make any difference because the well the I found some information on the internet with the same photo, like with the same picture that's depicted in the worksheet, and it says that A square plus B square equals to C square. So I don't since C square is since they all of them are squares, and all ln A, ln B, and ln C are squares, and the area is length times breadth, which is actually the square of the length. So I think that it won't make a difference because it's A square plus B square equals to C square. Yeah. So we have job prospect question 2. We use Pythagoras theorem to find the length of the fence. Question 2 is asking for the length of the fence between ln A and ln B, and the angle which is between the barrier and the fence along ln B. So we use Pythagoras theorem to find the length of the fence, which is 3 square plus 5 square equals to a fence square, and length of the fence square equals to square root plus minus 3 square plus 5 square. So the fence will equals to 5.8310 or negative 5.8310, which you have to reject. And finally, the final answer will be 5.83, which is to 3 significant figures. And for the second part of the question, which is we use sine rule to find the angle which they asked for. So it's 3 square plus 5 square. 3 square equals to 5 square plus 5.8310 square minus 2 bracket 5 bracket 5.8310 cos, which is cosine angle. So we have to bring the negative 2 bracket 5 bracket 5.8310 cos bracket angle over, and you have to expand it, so it equals to, you have to expand the other side also, so you have to equal, you will equal to 58.31 cosine angle equals to 50.000561. So the angle, to find the angle, you have to bring the cosine over and make it to inverse cosine, which is a negative cosine. So you have to have to bring over, and the final answer will be 31.0 degrees, which is to 3 SF. For question 3, we were asked to find the angle of the sun above the horizon. So basically, first we use TOA, so the trig ratio, but the TOA, so we use tangent angle over 3 over 2 equals to so the angle equals to inverse tangent 3 over 2, which is 56.310. So because it's a 90-degree angle, right, so we were using 56.310 to find the other angle from the 90 degrees. So you equal to 90 minus 56.310 equals to 33.7 degrees, which is accurate to 3 SF. Okay, so for job prospect question 4, this is the last question. For this question, we used trig ratios again, but this time we used SO to find the length of the ramp. So we let the length of the ramp be x. So sine 9 equals to 3 over x. So x will equal to 3 over sine 9. So the length of the ramp will equal to 19.2 meters. Yeah. So the conclusion is, even though we might not know it, but trigonometry is used everywhere around us. Yeah. Thank you.
Where is the one you say what missing?
Keep quiet. I'm not done yet.
Then you say thank you.
Wait, I didn't press done.